Failure of classical theory to explain the wave theory. According to wave theory, light is an electromagnetic wave consisting of electric and magnetic fields with continuous distribution of energy over the region over which the wave extends. Now, the wave picture of light could not be explained by this classical theory, and the reason behind that explained here. Now, we are going to discuss about that. Now, wave theory says that when a wavefront of light strikes on the metal surface, the free electron of the metal surface absorb a radiant energy. More will be the intensity of the incident radiation, greater will be the amplitude of electric and magnetic field, and greater will be the energy density of that wave, which is not satisfied the experimental results, which shows that kinetic energy of photoelectron does not depend upon the intensity of the incident radiation. Now, the classical theory says that whatever be the frequency of the incident radiation, the wave of sufficient intensity to give enough energy to electron to eject from the metal surface. Therefore, it cannot explain the concept of threshold frequency. Now, again, as per the classical theory, the energy of light wave is evenly distributed across the wavefront of the light. Each electron of metal acquires a small amount of energy. Hence, it will take finite time to escape from the metal surface. Hence, it is failed to explain the emission of electron from the metal surface, that is instantaneous phenomena or process. Now we talk about the Einstein photoelectric equation. Einstein used electromagnetic theory of radiation to explain the photoelectric effect. According to Einstein, the photoelectric emission is a result of interaction of two particles. The first one is photon and another one is electron of the photosensitive metal. The free electron of the metal surface bound within the surface, and they require a minimum amount of energy to escape from the surface of the metal, and that minimum energy is called work function. Each photon interact with one electron of the metal surface. The energy h nu of the incident photon is used in two parts basically. The one part of the energy of the photon is used in liberating the electron from the metal surface, which is equals to the again work function of the metal, and the remaining part of the energy of the photon is used in imparting kinetic energy to the ejected electrons. Now in this slide, if you see that by the conservation of energy, energy of the incident photon is equals to the maximum kinetic energy of photoelectron plus work function. So this energy of incident photon is equals to the maximum kinetic energy of the photoelectron plus work function here. Now if you put the value of this energy of the incident photon, that is h nu, we put the value of this energy of the incident photon h nu, and the maximum kinetic energy of photoelectron is taken as 1 by 2 mv square maximum, and work function is taken as w naught here. Now if you see that the k maximum, that is the maximum kinetic energy of the photoelectron, is equals to 1 by 2 mv square maximum is equals to h nu minus w naught, w naught representing again the work function here. Now put the value of this w naught, that is h nu naught here, this one, you are getting the equation here, and that equation is k maximum equals to h within bracket nu minus nu naught and bracket close here. You will get the equation number 2, which representing the Einstein photoelectric equation. This equation number 2 will represent the Einstein photoelectric equation. Now on the basis of this Einstein photoelectric equation, Einstein give explanation of this effect of intensity and the explanation of threshold frequency, kinetic energy and the time lag. Now we start with the explanation of effect of intensity. As the intensity of the radiation is increases, the number of photons striking on the metal surface per unit area also increases. As each photon ejects only one electron, so the number of electron is also increases with the increase in the intensity of the incident radiation. So that is clear to you. Now we are talking about the explanation of threshold frequency. As you see in this Einstein photoelectric equation, that K max equals to H within bracket nu minus nu naught, where nu is the frequency of the incident radiation and nu naught is the threshold frequency. Now if nu is less than nu naught, in that case K max become negative, which is not possible. Kinetic energy never negative. So in that case the photoelectron emission does not occur below the threshold frequency. Now in the explanation of kinetic energy, in that case if nu is greater than nu naught, that means frequency of the incident radiation is greater than the frequency of the threshold frequency. In that case the kinetic energy is maximum, and the maximum kinetic energy of the photoelectron is independent of the intensity of the radiation. Now we explain the explanation of time lag on the basis of this Einstein photoelectric equation. When the photon of the incident radiation strike the metal surface, there is a elastic collision occur between the electron and the photon, and during elastic collision the energy of the photon, or you can say that the photon gave its entire energy to the electron, and once the electron acquires the energy from the photon, it ejects from the metal surface immediately. So there is no time lag between the collision and the emission of the uh, electron of the metal surface. So on that basis Einstein explained that is the emission of electron is from the metal surface is a instantaneous phenomena.